Hi everyone. Hello. Good evening to all of you. So today we will be solving previous year's assignment 2. So it will be based on week two's content. Yeah, so it will be based on week 2 content of analog circuits. So we will be solving that uh, assignment of previous year. Okay. So let's start. So let's try to solve this one. चलो ये क्वेश्चन सॉल्व करो. आई एम गिविंग यू 4 minutes.
Excuse me, ma'am.
Yeah,
Can you give equation for option D?
can you? You're not audible to me
Transfer
very
function.
much. Huh.
ऑप्शन डी के लिए ट्रांसफर फंक्शन है.
Huh. Okay, okay. I will. See, so here there is no constant. So our k will be equals to 1. Here, see, this is how we have, right? So instead of any value here, we have k is equals to 1. So when k is equals to 1, we don't have any magnitude to start with. We directly will go, and this is a pole, right? So directly 1 upon s. We'll start with this 1 upon s into uh so yeah, 1 upon s till here. So this will become s by 10 plus 1, right? Since it was minus 20 and then it became plus 0, right? So a plus 20 happened here. So that means it's a 0, and at 1000 it again became like this. So that is something like this. So s divided by 1000 plus 1, and there is no pole, only zeros are here. So overall for this transfer function will be something like this: s by 10 plus 1, s divided by 1000 plus 1, right? And it's starting at 1 by s. So s will be here. Okay.
ओके मैम.
Hmm. Guys, did you solve it? हो गया क्या क्वेश्चन? एवरीबॉडी,
यस मैम.
सबका हो गया? क्लास का लिंक शेयर कर दीजिए. क्लास का लिंक उधर है. क्लास का लिंक, ये क्लास का लिंक है, और यहाँ पे मेरे रिकॉर्डेड वीडियोस रहेंगे. ठीक है, आई एम पोस्टिंग ऑल दीज थिंग्स हियर. सो एवरीवन डन?
Yes, ma'am.
हाँ, okay, cool. So here we have a 10, right? 10 as a constant is given to us. So from where it will start? It will start as 20 log 10. That means 20 dB, right? That means 20 dB, है ना? So it will start from plus 20 dB. So all of these are starting from plus 20 dB. Okay, great. So okay, so till now all of these are possible. Now see, s by 10 here and s by 1000. So what will come first? So a 0 here is given as 10, and a 1 by this thing 0 is 10, and a pole is 1000. So what will come first? हम इसको ऐसे उसमें लगाएंगे ना. वी विल अरेंज इट इन असेंडिंग, सॉरी, यस, असेंडिंग ऑर्डर. सो पहले 10 आएगा, फिर 1000 आएगा, राइट? पोल्स एंड जीरो सबको जब बोर्डे प्लॉट बनाते हैं तो वी पुट ऑल द पोल्स एंड जीरोस इन असेंडिंग ऑर्डर, एंड देन वी draw the curve. So here 10 will come first, right, in log w. So 10 came first, 10 came first, and here, so it's coming constant, right? So something like this is happening. Sorry, something like this is happening. So plus 20 dB, right? Now at 10, a 0 came, right? So 0 with 0 the slope will increase plus 20 dB. So इसको हमने ऐसे कर दिया. At again at 1000 what happened? Instead of a 0 a pole came, right? So इसमें हमने plus 20 में से minus 20 कर दिया and this. So this was plus 20 and it again became, after a pole it again becomes 0. Here it's also 0. So option C. Option C is the correct one. You have any doubt? समझ में आया क्या हुआ?
No, ma'am. Yes, ma'am. Yes.
सबको समझ में आया?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
किसी को कोई डाउट?
Ma'am?
हाँ.
Ma'am, if we solve the option D problem, so what is the transfer equation?
Transfer function. Yes. So
Yes, yes.
so see here starting only is happening with a minus 20. So if the starting is happening with the slope only, so the curve is something like this, right? If the curve is something like this, then we'll say the transfer function is s. If and plus 20, let's say the slope is plus 20 and it's starting like this, then the transfer function is only, what is our transfer function here? Transfer function is s. If let's say our function is starting like this, right, minus 20, then our transfer function will be ts is equals to 1 upon s, right? Now let's say if the transfer function is something like this, minus 40 dB. Our body plot is something like this, not transfer function. If our body plot is something like this, then the transfer function is 1 upon s square, right? Similarly, let's say our transfer function is something like plus 80 dB per decade, right? Then this means our transfer function ts is how much?
S cube.
No, s to the power 4.
Oh, okay, okay.
Okay, got it? So here also
Yes, ma'am.
1 upon s, then at 10 a 0 is being added, and then again at 10 another 0 is being added. Okay, any doubt?
Okay, ma'am.
Ha. Any doubt? Any other doubt? Anyone?
No, ma'am.
No. So let's go ahead. Let's see if we have solution. Yeah, so solution is something like this, s upon wc1 wc2. ठीक है? And we got something like this, pole 0. Let's go ahead and solve. So we solved question number 7. Let's solve question number 8. So what will be the value of x in dB or for the transfer function given below, where dotted curve is the exact Bode plot and the other curve is for approximate Bode plot. Okay, so this is the Bode plot given to us, and this dotted curve is said that it's the exact Bode plot, and the solid curve is the approximate Bode curve. Okay, and it's asked that what is the value of x here. ओके, एक्स पूछा है, एग्जैक्ट बॉडी प्लॉट दिया है और ये दिया है अप्रोक्सीमेट, एंड इट इज आस्क्ड कि एक्स बताओ, और कहाँ से स्टार्ट हो रहा है, प्लस 40 dB से स्टार्ट हो रहा है, एंड देन द स्लोप इज बिकमिंग प्लस 40 पर डेकेड. समझ में आया? क्वेश्चन समझ में आया सबको? क्या हो रहा है यहाँ पे? क्वेश्चन समझ में आया सबको?
Yes.
हाँ, ओके ओके. सो आई एम गिविंग यू 2 minutes. ट्राई टू सॉल्व दिस वन. Solve. Okay, see, done, right? Option B, 3D value is large initial. Done, everyone. ठीक है. So, uh, okay. So what happens here is, see, exact Bode plot is this one is dotted, right? And here we are adding two zeros of similar value, right? 10 10 का value का हम two zeros, that is omega z1 we are adding, not zero, should not say zero, we are saying omega. Okay, so omega z1 we are adding of same value, right? 10 10 का हमने add किया. So the slope, how much slope will be, and first k देखो यहाँ पे k is 100, right? तो 20 log k किया तो value क्या आ गई c की plus 40 dB, right? So plus 40 से start हुआ and at 10 both are of same value, so plus 40 dB per decade slope has changed, right? Now what happens is, when exact Bode plot we draw, then it has a, if we are adding a, let's say a pole is getting added, right? So it will be, exact pole will be some, and this will be, how much this value will be, this value is क्या difference होगा 3 dB का, and with every pole or with every zero this value gets increased by 3 dB. So if we are adding, let's say, two poles, it will become 6 dB, the exact plot ka difference. If we are adding two zeros, then it will be plus 6 dB, right? The difference will be plus 6 dB. So this is what is happening here. Two zeros are getting added, so the exact plot becomes, the difference in exact plot becomes plus 6 dB. So the answer here is plus 6. Any doubt?
No, ma'am.
Okay. Anyone else? Any doubt?
No, ma'am.
Good. Good. Okay. Cool then. If you have no doubt, let's go ahead. Similarly, another question I am asking, what will be the 3 dB frequency? 3 dB frequency for a given transfer function, given below transfer function, where dotted curve is for the exact Bode plot and the other curve is for approximate Bode plot. Okay. So this is the approximate Bode plot and the uh, dotted is what? Dotted is the exact plot, right? Now it's asked what is the 3 dB frequency. 3 dB मतलब यहाँ पे the exact and the approximate has a difference of 3 dB. So what is the frequency at 3 dB plot? 3 dB frequency. What will be the 3 dB frequency? So it's asked 3 dB frequency बतानी है अपने को. What will be the answer?
100.
Okay. Others, take a guess. What will be the answer?
100, ma'am.
So from transfer function here, it's a 100, right? So it's a plus 40. So it will start with plus 40 and then one plot is added, one pole is added at minus 20 dB, right? Something like this. This is 100. So 3 dB frequency matlab 3 dB, what does 3 dB frequency means? The approximate plot and the exact plot will have a difference of 3 dB. So this happens at the pole, right? And this happens at 100, right? So option C is the correct one. Got it? कोई doubt?
No, ma'am.
No. किसी को कोई doubt है? नहीं?
No, ma'am.
Plus minus 20 dB per decade. Okay. Let's go ahead. Let's solve another question. What will be the minimum value of x? Okay. for it to be dominant pole for the transfer function given below. Okay, so this is the transfer function given to us. Now what will be the minimum value of this x for it to be a dominant pole of the transfer function? So हमें एक ट्रांसफर फंक्शन दिया है, ठीक है, कह रहा है कि s प्लस 3x, तो 3x कह रहा है कि 3x इज अ डोमिनेंट पोल। अगर 3x को डोमिनेंट पोल होना है तो x की मिनिमम वैल्यू क्या होगी, ये क्वेश्चन है। तुम लोग को मैं 4 मिनट देती हूँ इस क्वेश्चन को सॉल्व करने के लिए, ठीक है। सॉल्व करो इस क्वेश्चन को एंड देन वी विल डिस्कस। solved, nearer to the origin is more stable pole. So multiplying the least value with 3 will give more towards the origin. Therefore 3 will be the answer. Close to 0 will be the dominant pole, right? 773 C 3 okay. हो गया क्या सबका?
Yes, ma'am. Yes, ma'am.
Hmm?
B.
What?
Yes, ma'am. Yes, ma'am.
हो गया? uh, everybody?
Ma'am, can you solve?
Yeah,
No,
everybody
ma'am.
done? Chalo ठीक है, let's go. See, so dominant pole. What does dominant pole mean? Dominant pole means के the pole which is most dominant over all the other poles, right? So what does that mean? That means ke, see, there will be many zeros and many poles in the transfer function, right? But at the end, what should happen is the dominant pole means if with this dominant pole the function becomes stable, more stable, right? So let's say the function is going something like this, right? With the addition of this dominant pole, it will become something like this. So overall, let's say this is the transfer function, right? Something like this something like this is happening, right? At the end, see, if it goes like this, right? If it continues to be going like this, the function is not stable. To make it stable, we need something, we need a dominant pole that overall, whatever is the function, whatever is the function with the dominant pole, it should become something like this. It should become stable. How it will become stable? It will become stable it's if at the end its slope is decreasing, or at the end its slope is at least constant, right? It's not increasing. If the pole is if at the end transfer function is still increasing, then it's not, there is no dominant pole. With the help of dominant pole, the system becomes stable, right? So let's see. No, not this one. Lecture C talked about dominant pole here. No, anyways, leave it. Okay, so if you have gone through the lectures of the NPTEL lectures, you would have known that dominant pole is at least 4 times greater than its nearest pole or zero, right? So dominant pole, what does dominant pole means? It dominant
Ma'am, can you show the screen once again?
Can you see? Yeah. So dominant pole will only be called dominant pole when it is at least 4 times greater than its nearest pole or zero. समझ में आया? Nearest pole और zero कोई भी हो, उससे 4 गुना बड़ा जो होगा उसको ही हम dominant pole बोलेंगे. Okay. Now with nearest pole, what do I mean by nearest pole? See, let's say 1, 2, something like this. Here a 0 is here, then a pole, then a 0, something like this is going on, right? So the nearest pole will be the greatest if we are not given dominant pole. अगर dominant pole की value नहीं दी है, but all the others are given, right? So here the highest value 5. So the 5 is the nearest pole to the dominant because something like this is going on, right? So 7, 8, something like this is going on. Similarly here 1, 2, 3, something like this is going on from here. So the nearest pole will be the greatest value of the 0 or pole. So here what is the greatest value of 0 or pole? So 0 is maximum, 0 is going till 4, whereas maximum pole is going till 5. So nearest pole or 0 will be 5. So this dominant pole, that is 3x, has to be greater than 4 times of nearest pole or 0, that is 4 into 5. So our 3x has to be greater than 20. So for the minimum value, what we can take it, this as 21. 21 will be greater than 20, right? So 3x has to be equals to 20, and it can be more also, it can be 22, 23, 24, 25, but since we are asking for the minimum value of x, we will take 21. So here x will be 7. Got it? समझ में आया क्या हुआ यहाँ पे?
Yes, ma'am.
मैम मुझे डाउट है ये 5 क्यों लिया मैम, मेरे को समझ में नहीं आया.
5 इसलिए लिया क्योंकि हमको चाहिए नियरेस्ट जो भी सबसे ज्यादा वैल्यू का होगा. ठीक है, मान लो कि अगर हम ले लेते, तो अगर हम 2 लेते और फिर हम इसकी डोमिनेंट पोल निकालते तो 5 पे रह जाता ट्रांसफर फंक्शन में. तो अगर 5 है ट्रांसफर फंक्शन में और हमने 2 को ले रखा है, तो उसका मतलब है ना कि हमने डोमिनेंट पोल चूज नहीं, डोमिनेंट पोल की वैल्यू सही नहीं आएगी. क्योंकि देखो ओवरऑल क्या आना चाहिए, ओवरऑल हमें स्टेबिलिटी से मतलब है. तो जो सबसे बड़ा 0 का वैल्यू या पोल का वैल्यू होगा, उसी से तो हम डोमिनेंट पोल को कंपेयर करेंगे. क्योंकि अगर हम उसके पहले किसी भी वैल्यू को कंपेयर करते हैं तो हमारे पास एक वैल्यू रह जाएगी पोल या 0 की, जो कि अभी भी ट्रांसफर फंक्शन कैसा जाएगा उसको डिफाइन करता होगा. समझ में आ रहा है? आर यू गेटिंग मी? सी yeah, let's say हमने instead of 5 we chose 1, right? So if we choosing 1, then dominant pole will be 4 into 1, right? Minimum value will be 4 into 1. So dominant pole became 4, but there is a 5 already there in the system. So when the transfer function will be changing and we are saying that we are taking 4 as a dominant pole, but then 5 is there in the system and due to 5 the function will change. So we cannot say that 4 is the dominant pole. We have to take the highest value of the pole or 0, so that from there we choose the dominant pole.
Now I understand मैम, थैंक यू. Got it.
डोमिनेंट का मीनिंग क्या है? जो सबसे ज्यादा बड़ा, सबसे वैल्यू जो डोमिनेट कर पाए पूरे फंक्शन पर. वो पूरे फंक्शन पे डोमिनेट कैसे कर पाएगी? जब वो सबसे बड़ी वैल्यू होगी. तो जो सबसे बड़ी वैल्यू है उसमें हम 4 मल्टीप्लाई करके जो वैल्यू लाएंगे वो डोमिनेंट पोल हो जाएगा, ग्रेटेस्ट वैल्यू. समझ में आया?
यस सर.
मैम अगर s प्लस 5 की जगह s माइनस 5 दिया रहेगा तब भी 5 ही चूज करेंगे या फिर 4 हो जाएगा?
s माइनस 5 दिया होगा तो फिर वो 5 पॉजिटिव हो गया ना, तो वो हमारा प्लस 5 हो गया, तो हमारा फंक्शन ऑलरेडी अनस्टेबल हो गया. सिंस हम स्टेबिलिटी कैसे डिफाइन करते हैं? स्टेबिलिटी को डिफाइन करने के लिए हमें चाहिए कि कोई भी सारे जो पोल्स एंड 0 हो वो लेफ्ट साइड में आए. लेफ्ट साइड में अगर कोई भी वैल्यू राइट साइड में आती है, then it's what it will become unstable. But again फंक्शन हमारा अनस्टेबल हो गया, तो हम we cannot use this thing. We cannot use dominant pole concept there because it's already unstable. The function became unstable.
Yes, ma'am.
Ma'am,
Go ahead.
so the dominant pole concept we see dominant pole from the perspective of from the left side only.
Yes.
If we have a pole like on the left hand, तो मतलब मैम जीरो ओरिजिन से नहीं देखेंगे, हम लेफ्ट साइड से देखते हैं कि भाई पोल जो है वो कहाँ पे है.
हाँ, पोल नहीं, मतलब ग्रेटेस्ट वैल्यू पोल की कहाँ पे है, उसके बाद हम डोमिनेंट पोल सेलेक्ट करते हैं. देखो यहाँ पे हमारा लो फ्रीक्वेंसी रिस्पॉन्स है, हाँ, तो हमारा S प्लस ओमेगा Z1 प्लस ओमेगा Z2 ऐसा कुछ आया है, प्लस 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 दोनों साइड, राइट? So for low frequency response, it is a low frequency. We are talking about low frequency response only. We are not talking about high frequency response right now. In next module, we will be talking about high frequency response. Here we are talking about low frequency response. So for low frequency response, transfer function is something like S plus omega Z1 plus Z2 plus ZL omega, ठीक? So you can see that जब हमारा S omega ZL जब हमारा इन्फिनाइट जाएगा तो हमारा H क्या हो जाएगा, 1 हो जाएगा, राइट? और जब हमारा S इज इक्वल टू 0 होगा तो कुछ ऐसी वैल्यू आएगी, ओमेगा Z1 इंटू ZL, ऐसी कुछ। ओमेगा Z और ओमेगा V की अगर सूटे सेलेक्ट करते हैं तो हमारा H ओमेगा की वैल्यू एक सूटेबल आएगी और हम उसको ले सकते हैं, मतलब इट वोंट बी अनस्टेबल। समझ में आ रहा है? समथिंग लाइक दिस। यहाँ पे हमारा वैल्यू कुछ भी हो, ठीक है, हमारा H ओवरऑल हमारा H अगर ऐसा जा रहा है, बट एट द एंड अगर वो स्टेबल हो जाता है तो जो पोल की वजह से वो स्टेबल होगा उसको हम डोमिनेंट पोल बोलेंगे, ठीक? आगे जाते हैं। अगर ये क्लास करोगे तो समझेगा कि हमारा जो ओमेगा P1 है, जिसकी वजह से हमारा ये आ रहा है, वो एटलीस्ट 4 टाइम्स ग्रेटर होना चाहिए, तभी एट द एंड हमारा जो सिस्टम है वो स्टेबल बन पाएगा, अगर अनस्टेबिलिटी के साइड कहीं जा रहा है तो। अंडरस्टूड?
Yes, sir.
Yes, ma'am.
So this is for low frequency response. Do you have any doubt here? Got it, right, everyone?
Yes, ma'am.
Yes, sir.
Ma'am, can you do a small favor, ma'am? Ma'am, I joined few minutes back, ma'am. Can you share the solution for that? Ma'am, I did not listen to the class.
Okay. Okay, I will share this.
So will I get? So or else the recording class is also, okay, ma'am.
Yes, so I have recorded the session. I will share it with you. See here, I have shared the link. I will share it with you again.
Ma'am.
Okay.
Yes, ma'am.
So this, so you can go to this.
Ma'am, one more doubt, ma'am. Ma'am, for week there are 3 sessions problem solving. One is Friday, Saturday, and Tuesday. Will the 3 sessions will have the same content?
Yes, it will. So different.
If we attend today, I have attended. I can skip Saturdays and Tuesdays
Yes,
session.
you can skip. Yes. Yes.
And one more thing, ma'am, you have shown some material like PDF, no? From where we can get the PDF of related course, ma'am?
Yeah. So okay. So on my channel, I will be sharing one link also. So from there you can copy the link and all the material, like even the lecture transcripts of the lecture, and my solution and my question, and for the quizzes, everything will be uploaded there. Okay, so let's say I will show you how to go there. Okay, so let's say you went to my YouTube channel. See, I have shared the link, right? You can copy paste the link and go to the my YouTube channel. So something like this will be appearing here. So you can go to my YouTube channel, and here I have shared a Google Drive link to you. See here. Okay. Now once you will click this, all the material for quiz 1 I have uploaded. For quiz 2 also I will upload it today. So same link you can use for all the other quizzes. So all the material will be uploaded here in the link. I'm going to share the link also with you here. Okay, so you can check it out. thing I will post. How can I download a PDF or analog circuit? PDF of analog circuit. Matlab, what do you mean by that? All the lecture PDF. Are you talking about that?
Yes,
Yes,
ma'am.
I will put it in the link only. This link here. This link I will put it here. Any other doubt? Anyone?
No.
No. Okay, so all the best for quiz 2, assignment 2 for you. And okay, so I'm done today. And if you have any doubt, you can post it on my comment section, or here also I will try to solve. If not, there is announcement ask question section in the NPTEL portal also. There also you can ask question if you have any doubt. Okay, and all the best. I'm done with my session.
Thank you so much, ma'am.
Okay, welcome.
Thank you, ma'am.
Yeah, okay.
Thank you, ma'am.
Thank you.
Welcome. Bye. Bye bye everyone.
Take
Ma'am,
care.
there is a question.
Bye,
Okay,
ma'am.
you have question, you ask then.
Ma'am, if you solve any other questions, if you want to get a solution for that, can we share the questions to you and we can get a solution for that?
Any other question? What does that mean? Like,
I mean, if you do any from any other reference books or something like that, if you get any doubt or something like that
I can
related to the analog
okay,
circuits.
I can try to solve those questions, but since we are on limited time, I don't think we will get time to solve extra question. But you can definitely send it
Yeah,
on
okay.
this portal. NPTEL portal is there, so you can definitely try asking questions from there. Uh, okay.
Yeah,
So
okay.
we are restricted on time,
Yeah,
right?
sure.
So if everybody gets question from reference books and do that, then we won't be able to solve everything, right?
Yeah, yeah. Okay.
Yeah.
Okay.
But मतलब
Thank
छोटे
you.
मोटे question, if 1-2 minute, if that.
Yes, ma'am. Only the related to the topics what we are
Yeah,
discussing
you can do that.
discussed here.
You can do that.
Yeah, thank you.
Okay. Ma'am, resend Google Drive link, please. Hey, just ऊपर it's there. हाँ. Okay, so I don't think anyone has any doubt. So we are leaving. I'm going to leave the session. Stop sharing. So I'm going to leave the session. Bye. All the best.